Okay, welcome back. Um, we have question 2, and again, area between curves. And we can see from here, we can know how many integrals we're gonna have. We're gonna have 1, 2, 3. But we also know we're gonna have to find our points of intersection, which we can easily see just by zooming in. We know it's 1 and 3 from 0 to 4, as we know in the problem. But it's still good practice to find our points of intersection by setting our f of x equal to our g of x, which is 3x squared minus 12x plus 9 equal to negative x squared plus 4x minus 3. And we just move everything to one side, gives us 4x squared minus 16x plus 12 equal to 0. And just finding our roots, we can take a factor of 4 out. Perfect. And then from that, we can just find our roots, which is x minus 3, x minus 1 equals 0, which means x is equal to 1 and 3. And that verifies from what we see in the graph. And that's how you're going to do it every single time to find our points of intersection. So now we have to set up our 3 integrals from 0 to 1, 1 to 3, and then 3 to 4. And while this, we're going to keep in mind top minus bottom when finding the area. So from 0 to 1, we have dark blue minus dark red. So that's going to be 3x squared minus negative x squared, which is positive 4x squared. So honestly, it's just what we did over here. This should be our integral. So 0 to 1 of 4x squared minus 16x plus 12x dx. And now we just use the normal power rule to solve this. Nothing too fancy. From 0 to 1, we know everything else is just going to be 1 because 0 will cancel everything else. So 1 is just 4/3 minus 8, not plus 8. And then plus 12. This is just 4. 4 plus 4/3 is 16 over 3. Yes. So 16 over 3. Let's keep that in mind. And then we have our second integral from 1 to 3. Now it flips. So we are subtracting. So it's going to be negative 4x squared plus 16x minus 12 dx. So similar process using power rule. Oh, that should just be x, I believe. Or no, it should be x squared, yes. It should be x squared as well. And this should be minus 12x. Perfect. 1 to 3. And then now this also is going to be just 16 over 3. Perfect. Once you plug in everything, I'm not going to go through plugging in all the numbers every single time. But as long as you know, you're going to start with 3, plug in each x, and then subtract from plugging 1 into every single time. And that'll yield you 16 over 3, 16 over 3. And our last integral from 3 to 4 is going to be the same one from here. 4x squared minus 16x plus 12x dx. And it is just the same exact solution as our first integral above. And since we're only 1 away as well, it will yield the same solution of 16 over 3. And then you add that all together, it's 3 16 over 3s, which means it is just 16. That is our solution to this problem.